This case 6, it is the line is inclined to both HP and VP. So the line inclined to both HP and VP, it is nothing but the actual problems in projection of planes. Okay, so now we are dealing with the actual problem. So you can see here the line AB 80 mm long has its end A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degree to HP and 45 degree to VP. Okay, so first I'm going to draw an XY line here. So XY, VP, HP. So in this problem we have to draw the projections of the line and find apparent lengths and apparent inclinations. As we have discussed, apparent lengths are nothing but the reduced lengths. Okay, reduced lengths we have to find out. So first the end of the line, it is inclined end A, it is 20 mm above HP and 30 mm in front of VP. So 20 mm above HP, so this is 20 and 30 means here. Okay, so you can show the dimensions for it. So this is 20 and this is 30. The end of the line. So here the length of line, it is 80 mm. So AB, it is nothing but true length. You have to find out the upper end length. So angle of inclination, they have given 30 degree to HP and 45 degree to VP. So first you are going to take the angles. So 30 degree inclinations. So 30 degree, mark at 30 degree and draw a line of length 80. So from this end, for this point, you have to mark till 80. 80 means 8 centimeter. Okay, so he is having an angle of 30 degree. Okay, now similarly you have to mark at 45 degree, 45 degree to VP. And here line of length again 80. Here we can show the angle. So this is 45 degree to VP. So you can show the lengths here. So this is having 80 mm. So this is 80 and this also 80. So these are nothing but the true lengths. So here we are going to give the naming for this. This is A dash, this is B1 dash, and this is A, and this is B2. And here after drawing this, we have to draw the locus lines here. Okay, so drawing the locus line is very important. Okay, drawing the locus lines is very important. So locus lines we have drawn. Now we have to find out the upper end lengths. Okay, so how to find out the upper end lengths means here from this end, so we have to draw a straight line till this. So I'm going to mark this as a locus of A dash, and this is locus of B1 dash, and this is locus of B, and this is locus of B2. Okay, so from B1 dash we have to draw a straight line till the locus of A. So till the locus of A we have to draw. So you can show the RMR direction. Now after this we have to measure this length from here to here. Measuring this length, we have to cut the arc. Okay. So this point, I'm going to give this one as B1. Okay. So where the arc has been cut, we have to join from here to here. So this is AB. This is AB. The same way from B to vertically upward till locus of A dash. So I will draw a straight line. So this is B2 dash. So by measuring from compass, measuring from compass from here B2 dash, so we have to cut the arc till the locus of B dash. Now we can join where the arc has been cut. This is A dash B dash. Okay, so this is nothing but the apparent length. So this A dash B dash. Okay, apparent length we are going to measure how much it is. Apparent length, it is measuring 57 mm. Okay, so okay, 57 mm apparent length. And this length we are going to measure. This is 67. 67. Okay, 67. And apparent angles, inclinations also we have to find out. So how much we are getting. So apparent length, inclinations, here we have 45 degree. Okay, and this one we have, around 50-60 degree. Okay, so we're getting apparent lengths A dash B dash 57 mm and AB 67 mm in the angles. Okay, 45 degree and 60 degree. Okay, so this completes the problem. Okay, so we are going to solve second problem from the CAD solution book. Okay, in the projection of lines. Okay, in this problem, line AB 80 mm long is inclined at 30 degree to HP and inclined to VP at 45 degree. So draw the front and top views of the line and determine their length. So in this problem they have mentioned true length and the angle of inclination to HP and an angle of inclination to VP they have given. Now we have to find out the apparent lengths and apparent inclinations. Okay, so proceed with the problem. So first I am going to draw an extra line here. Okay, so any one of the reference point I will take here. This is A dash and A. Okay, here, so they have not given any end of the line distance, so no need to draw the locus. The locus line, it is there on the XY. So first inclination, it is inclination to HP at 30 degree, and here we have to draw a line of length 80 passing through this point. So this is 30 degree. This is B1 dash. Similarly, we have to mark another angle at 45 degree, and this also having a length of 80. So this is B2. Now we are going to draw a locus line here. This is locus of B2 and this is locus of B1 dash. Okay, so now the procedure here it is, we have to project it downward till here. Now we have to take the compass, measuring from here, so we have to cut the arc. This then we have to join. Okay, so I'm going to arc this length, and this is our apparent length AB. Now we have to project it upward, so arrow mark I'm writing here. So we have to join here. So this is A dash, B dash. Okay, there are two apparent lengths we got. Now we have to measure the angle. Okay, apparent length angles. So here we have, so it is around 45 degree. This is alpha 45 degrees. And this is beta. We will give. So this is we are getting beta 55 degree, and this is 45. So we need to measure these lengths. This is around 57 mm. So we will write here A dash, B dash 57 mm, and AB. So alpha we are getting 45 degree. So beta we are getting 55 degrees. AB length we have to measure. AB I am getting around 68 mm. So these are the things we have been find out. Okay, in projection of line. You can like the video, subscribe and share, and hit on the bell icon. Okay, we see another problem, that is problem number 3 from CAD solution book. Okay, so in this problem they have given line AB as its end A 20 mm above HP and 30 mm in front of AP, and the other end 60 mm above HP and 45 in front of AP. Okay, and the distance between the projectors, end projector is given 70. So in this problem they have not mentioned either true lengths or any kind of inclinations. Okay, we have to use these end line distances so to do the problem. Okay, so now we are going to proceed with the problem here. First I am going to draw an XY line. Okay. So XY AP HP. So one end of the line is 20 mm above HP and 30 mm in front of AP. So 20 here and 30 here. Okay. So here we are going to show the dimension. So this is 20, this is 30. This is A dash and this is A. And then other end is 60 mm above HP. Okay, 60 mm above HP. So that is 6 boxes. Consider 60 here, 60. So what I will do 60 it is, and here it is 45. Okay. So this is 45. Now I am going to draw the locus lines here. Okay. Okay, this is locus of B1 dash. This is locus of B2. This is locus of G, and this is locus of A dash. Okay, now another thing what they have given in this question is distance between projectors. So distance between end projector is 70 mm. So I'm going to draw that. So here distance between end projector is 70. So here I'm going to draw on vertical line. Joining it. So here I'm going to mention this is B dash and this is B. We know that as the apparent lines were drawn, so the end points, if you draw a straight line, so it will be falling in a straight line. Okay, so that's why we're getting this B dash and a B on a same line. So I'm going to join this. So this is apparent length 1 and this is apparent length AP. Okay, so these 2 points we are getting it. So now using these 2 points we are going to draw, we are going to find out the, okay, so reverse here. So in this problem we have to do the reverse process to get the 2 lengths. Okay, so now we join from here. So this is B2. Okay, that is 1 2 length. Now again from this end so I can show the arrow mark direction in which these things are going. So now we will join this. Okay, so we'll find out the distances here. So 2 length we are getting around AP2 and A dash P1 dash, it is 82 mm, and AB we are getting around 72 mm, and this is B1 dash, 81. So AB1 dash is 81 mm. So we have to find out the angle of inclinations for the 2 rings, okay, or apparent lengths. So here we are getting around 30 degree alpha. So alpha here we are getting it is 30 degree, and beta we have to find out. So beta we are getting around 20. Okay, so this problem it is done. Okay, we solve another problem from CAD solution book, that is problem number 5. Okay, so what is given in the question? The top weave PQ of a straight line, the top weave PQ of a straight line is 70 mm. So they have given the top weave of 70 here and makes an angle of 60 degree with XY. The end Q is 10 mm in 10 end Q is 10 in front of VP and 30 mm above HP. The difference between the distance of PQ, P and Q above the HP is 45. So draw the projections and determine its true length and true inclinations with HP. First we are going to draw the end points. So for that first I am drawing an XY line here. Okay. So VP, HP, Y. So end Q distance given. So end Q it is 10 mm in front of VP. So from here it is Q and 30 mm above HP. So here it is Q dash. So we will show the dimensions. This is 30 and this is 10. And here another thing, the difference between the distance of P and Q above the HP is 45. So the distance between this P and Q, we have to consider the distance of 45 here. From this here, I'm going to consider 45 here. Sorry, till here it is 10, 20, 30, so 45. Okay, so here I'm going to draw on locus. And here also I'm going to construct a locus line here. Okay, and here also the locus line. Okay, now so with the question they have mentioned, so the top V PQ of a straight line 70 mm. So 70 mm, so with the angle of 60. So here, keeping at this point, so marking at 60 degree, I'm going to draw 60 mm line here. So this is having inclination 60 degree and this is P. So here I am going to draw a locus line, another locus line here. Okay, so now to find out the true length, this is one of the upper end length, right? So upper end length, so upper end length will always be rotated, you remember it. So upper end length, it is going to rotate it like this, and then projected upward, so to get the true length. This is true length. So this is, so you can say P1 dash, P1 dash. Now so we are getting one upper end length and one true length. Okay, so now we have to get another upper end length. How to do? We know that upper end lengths, when they have been projected, so they are falling in a straight line. So I'm just drawing a straight line here. So this point we having, this is P dash. So now we are getting another upper end length in front view. Okay. Upper end length in front view. Now we are going to rotate this upper end length. Okay. So in this direction, then projecting downward. So this is, we have another true length. So we are going to measure the true length. So true length, we are getting around 76 here. Okay, so you can write here, so you can like write it Q dash P1 dash is equal to Q P2. So you can measure here. It is around 75 mm we are getting. Okay, and true angle of inclinations we have to find out. So the first angle we are getting, it is around 37 degree I'm getting. This is side 37 degree. Okay. And second angle I'm getting around, so this is theta and this is psi. So psi I'm getting around 45 degree. So this completes the problem. So remember it. So always upper end lengths are going to be rotated. Okay, so I'm going to make this upper end length darks. Okay. So apparent lens are always rotated. So true lens are never be rotated. Okay. So remember it. This is one of the important point. So apparent lens are rotated using compass. Okay. So we never rotate true lens. So this is one of the important note, you can say that. Okay, apparent lens are always rotated when we are doing the problem. True lens were never rotated using compass. Okay, so that is important thing. Another problem from CAT solution book. It is problem number 6. Okay, so in this they have given line PQ, true length 85 mm long, as a end P 10 mm above HP and 15 mm in front of VP. In the top weave and front weave of line PQ are 75 and 85. So these are the apparent lengths they have given. So this is true length 85. These are apparent lengths. So using these things we have to solve the problem. So we have to find out the true and apparent inclinations in this. Okay. So first I'm going to draw an XY line here. So XY, VP, HP and Y. So the end points first time write 10 mm above HP. So 10 mm above HP and 15 mm in front of VP. So here I'm going to draw a locus line. So wherever the end points were there, we have to draw an locus lines. Okay. So this point is P dash and this is P, and it is having a dimension of 15 and this is 10. Okay. In the top view and front view of line are 75 and 80. So the top view here, so this here on the HP plane we get the top view, so it is of 75. I'm going to measure 75 from the scale. Okay, 75 from the scale I'm going to measure, and here I'm going to cut the arc. Okay, and then I'm going to extend this. Okay. Extend it with a straight line. Now I'm going to measure 85 from the compass and using scale. You can measure and you can cut the arc. Okay. So then join. So this is having 85 mm and true length it is 85 and this is Q1 dash. So here on locus line here. Okay. So now we are getting the true length 85 here and the locus line. So next thing we have to do is again we have to consider this. The front view we have 80. Take here from the scale 80. So from this end I'm going to draw a vertical line here downward. Then again I'm going to measure 85 from the scale using compass. Okay. So now I'm going to cut the arc here. So here is another true length. Okay. This PQ2 is also 85 mm. Okay, so 85 here we get another locus line. Okay, so now using this 75 mm here, we're going to cut the arc exactly here. This here we're getting the upper end length PQ, and here upper end length PQ dash. Okay, now we have to find out the angles. Okay, find out the angles. So first I'm going to find out the theta. So theta I'm getting around, so much theta, it is around 28 degree. Okay, psi we have to find out. Alpha also, alpha is going to find out. So alpha I'm getting around so alpha I'm getting around 28. Alpha I'm getting around 28 degree here. Now psi we have to find out. Psi we have 20 degree, and beta I'm getting around 23 degree. Okay, so this completes the problem. Okay. We do another problem from CAD solution book. It is problem number 7. Okay, so what is given? A line has its end 10 mm above HP, 15 mm in front of VP, and end B is 15 mm above HP. The line is inclined at 30 degree to HP and 35 degree to VP, and the distance between the end projectors given is 50 mm. So now we have to use we have to go step by step here. So first I'm going to draw an XY line here. Okay, XY VP HP, same points, 10 mm above HP means this, and 15 mm in front of VP, and here we have locus line, and here also we have locus line. Okay, so this is A dash and this is A, and it is having a dimension of, so this is 10 and this is 15. Okay, now another end we have, that is 55 mm from here, that is, so 55 is still here. So here another locus. Now, so we have to use inclination. The line is inclined at 30 degrees. So this is nothing but inclination to the true length. Okay, so from here we are going to mark for 30 degree. Then we are going to draw a straight line passing through a point. Okay, so this is 30 degree and this is B1 dash true length. Okay, and another one is 35 degree to VP. I'm marking at 35 degree and draw a line. We have to find out how much length. So because we know that true lengths are same in both top view and front view, so we have to use this. So here we have true length, I'm getting around 88. So it is 88 mm. So this is the true length. So here also we have to draw another this is 35 degree Okay.
Open CS 90, civil 30. Civil EC CS ಎಲ್ಲ ಸೇರಿ 110 ಜನ. ECನೂ ಅಷ್ಟು ತಗೊಳ್ಳಿಲ್ಲ ಅನ್ಸುತ್ತೆ. ಈಗ 2 ಸೆಕ್ಷನ್ ಆಗುತ್ತೆ, 2 ಫ್ಯಾಕಲ್ಟಿ ಬೇಕು. 2 ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲ CS 2 ಸೆಕ್ಷನ್ ಮಾಡಿ ಸಿವಿಲ್ ಸೆಕ್ಷನ್ ಮಾಡಿದ್ರೆ ಒಂದು ಗ್ರೂಪ್ ಆಗಿ ಬೇಕಾಗುತ್ತೆ. ಅಂದ್ರೆ ಯಾವ ಸೆಮಿಸ್ಟರ್ ಅಂತ? 6th. ಅವರು ಅಲ್ಲಿ 45 ಮಾಡಿಬಿಟ್ಟು 2 ಸೆಕ್ಷನ್ ಮಾಡಿ ಸಿವಿಲ್ ಅಲ್ಲಿ ಸೆಪರೇಟ್ ಮಾಡೋದಂತ ಮೇಬಿ ನೀವು ಬರ್ಬೋದು. ಯಾಕಂದ್ರೆ ಇಲ್ಲ ನೀವು ಬರ್ಬೋದು, ಇವ್ರು ಹೋಗೋಕ್ಕಾಗುತ್ತೆ. 3 ಸೆಕ್ಷನ್ ಮಾಡಬೇಕು ಹೋಗಿಲ್ಲ.
So now we have to find out the angle here. So apparent angles we have to find out. Alpha, I'm getting around alpha 32 degrees, and here beta I'm getting around 44 degrees. Okay. And true length we have a dash, b1 dash, and a b2, it is around 88 mm. So that completes the problem. Okay, we solved the problem number 9 from CAT solution book. So it is, you can see in this problem they have given line of AB 60 mm as one of its extremities. Extremities means end point. Okay, so 20 mm in front of VP, 15 mm above HP. The line is inclined at 25 degree to HP and 40 degree to VP. So now we'll proceed with the solution here. So first I'm going to draw an XY line here. Okay, it's VP, HP, and Y. So end point here 15 mm above HP, 15 mm, and it is, and 20 mm in front of VP, 20 mm in front of VP here. So here we are going to draw an locus line. This is 15 and this is 20. Okay, 15 and 20, and this is A dash and this is A, and we have angle of inclination here. So 25 degree to 25 degree to HP. Okay, and 40 degree to VP. So 40 degree to VP. Here the length of line we have to draw, that is 60. Okay, here to these extremities again another locus line. So this is the AB2, another length of line 60 we have to draw this end. Okay, here another locus line. Okay, so this is B1 dash, and show the dimension here 60. We can show the dimension. See this angle, it is 25 degree. This angle it is 40 degree. Okay, so now this is true length. Now we have to find out the apparent length. So apparent length, it is going vertically downward till the locus of A. Now we have to take the compass and we have to rotate it till here. Okay. So here at this point we are getting apparent length AB. So we have to dark this apparent length. Okay. Now from this side this is what I want to tell. So if you just draw a straight line connecting the upper lens top face and the bottom face, okay, so this front view and top view, it is drawn, you'll get the straight line, okay, that is what. So you can see a dash and a dash, a it is in the collinear line, and b dash and b in the collinear line, okay. So this completes the problem. Okay, now we can find out the apparent length angle inclinations here. So apparent angle we have, so first angle we have here is around alpha is 34 degree, and this we have, it is around beta. So beta angle we are getting around 46 degree. Okay, and then apparent length we have to find out. Apparent length, this is AB we have 55 mm, and B dash we have 46 mm, dash B dash 46 mm. Okay, so this completes the problem. You solve problem number 10 from CAD solution book. So in this line AB measuring 70 mm has its end 15 mm in front of EP, 20 mm above HP, and the other end B is 60 mm in front of EP and 50 mm above HP. So first I'm going to draw an XY line. BP, HP and Y. So 20 mm above HP means here 20, and 15 mm means here. So here we're going to draw an locus line. above HP. It's 50 and 60 mm in front of EP. So here also we can draw an locus line. So this point it is A dash and this is A. So we have a line of 70 mm. So we have to measure 70 mm from 70 mm means 7 cm from the scale. Okay. So and we have to cut the arcs from this end to here, first arc, and the second arc from this here to here. Okay. So now we have to join. So these are nothing but two lengths. Okay. A, B, 2, and here from this end to here, this is B1 dash. This is having exactly 70 mm. And this also 70. Okay, now so projecting upward this line here, and from here we have to rotate this apparent length till here. Okay. This is B dash. Similarly, so we can project it downward till here, and measuring from here to here we can cut the arc and can join this. This is AB. So now we can measure the length here. So A dash, B dash, it is around 55. so sorry, not 55, it is around a dash dash b dash. So we have to find out here inclinations, okay, not the length here. You can see here, find the inclinations. We have to find out the inclinations here. So inclinations, what we are getting, both the inclinations we are getting. First angle we are getting around, it is theta in 125 degree here. This is 25, it is theta, and alpha we are getting, this is 34. Now here psi we have to find out. Psi we are getting around 45 degree. This is psi. Okay. This angle getting around, it is beta we are getting 55 degree. So sorry, psi we are having 40 degree. And this beta we are having, it is 45. So you can mention the angle here: theta 25, alpha 34, psi 40 degree, and beta 45 degree. Okay, so this completes the problem. Okay, so when you are doing it, so always make sure you have to dark this upper end length. Okay, you have to dark the upper end length. The upper end length has to be more thick compared to your true length.